Let's hear, hold on. Let's hear more bass in the earphones and more of the slide guitar and a touch less of the piano. Seems loud.
Good morning, ladies and gentlemen, and welcome to day 2 of Human After All, Innovation Disruption Society. My name is Fred Kuntz. I'm the Vice President of the Center for International Governance Innovation, or CIGI, as we say, and we are co-sponsors with the Institute for New Economic Thinking in this conference. This morning's breakfast session explores George Soros' theory of reflexivity and the methodology of economic science. In December, the Journal of Economic Methodology published a special issue on the theory of this panel, on this theory, and this panel features 4 of the leading scholars who contributed to that edition, and they are Roman Frydman, Professor of Economics at New York University and Chair of INET's Program on Imperfect Knowledge Economics; Hommes, Professor of Economics at the University of Amsterdam; and Alex Rosenberg, who is the R. Taylor Cole Professor of Philosophy at Duke University. Our moderator for this session is Eric Beinhocker, Executive Director of the Institute for New Economics Thinking at the Oxford Barton School, University of Oxford, where he leads a research center devoted to applying leading-edge interdisciplinary approaches to economic theory and public policy practice. Please join me in welcoming Eric and the panelists.
Good morning. Well, I have to say I'm hugely impressed at the turnout for this very early session. We were talking before, we were saying we were kind of expecting to come into an echoing hall here, given both the early hour and the deep philosophical nature of our topic this morning. But I just want to check a show of hands. How many of you are jet-lagged Europeans who just couldn't see? Okay, that explains the turnout, I think pretty well. But the meek may not inherit the earth, but early risers will. So thank you for coming. Now, the origins of this session really began 2 years ago at the INET conference in Berlin. Many of you were probably there and might recall that George Soros gave a speech on his latest thinking on reflexivity, a topic he's been working on really through his whole life, and drew out implications of that for the Euro crisis, which was the main topic of the Berlin conference. And a panel of distinguished economists was assembled to respond to George's speech, and a very vigorous debate ensued about some very fundamental issues about the nature of the economic system, what can we know about it, Knightean uncertainty, human fallibility, a whole set of issues. And in the audience were Wade Hands and John Davis, the 2 editors of the Journal of Economic Methodology. And after the session, they came to Rob Johnson and I and said, that was a terrific debate. We need to have that debate in an academic journal. And so they commissioned the special issue of the Journal of Economic Methodology to look more closely at Soros's ideas and what they mean for economics. And a group of 18 scholars was invited to contribute articles to it. And there were 2 workshops on the topic that Central European University very graciously hosted. And the result of that work came out in December, and there are copies of the journal available for free outside on the tables in the hall, and it's also available for free download. And what you'll see in the journal is that George's ideas on reflexivity being taken very, very seriously and brought right into some very core debates about what is new economic thinking and what kind of an economics would better describe the real world that we have of financial crises and innovation and growth and all the topics we've been talking about here in Toronto. And I should just note that the issue has generated quite a bit of interest. There's already been 20,000 downloads of it, even just in the first few weeks of it being available. And it's my great pleasure that we have three of the contributors to the issue, Hommes, Roman Frydman, and Alex Rosenberg. I'm going to just kick things off with a few brief remarks about what reflexivity is, what kind of a system that implies the economy is, so really a question of ontology, what is the economy? And then what does that imply for what can we know about the economy? Epistemology, what are our limits to knowledge in understanding economic systems? And I think that question fits very well with this human after all theme of the conference. What can and can't we know about the economy? So just to dive right in, this is a chart that appeared in Soros's piece in the GEM issue, where Soros tries to lay out in pictorial form what does he mean by reflexivity? What's the definition of a reflexive system? And what you see in the picture is that you have multiple agents, people, and each person has their own subjective reality, their own view of the world and how it works. They have some intentions, some things they're wanting to do, and then they try to manipulate the world to fit with their notions of reality. But in manipulating the world, we're all fallible. And George goes into great detail on different sources of fallibility, but it means that there's a disconnect sometimes between our intentions and our actions and the results that are achieved in the world. That then feeds into objective reality. We then have some information flowing back from objective reality back to our minds, to what George calls our cognitive function. But again, fallibility steps into the picture, that we don't always perceive the world perfectly. There's lack of information or misinformation. Our own cognitive capabilities are limited and so on. That then leads to our perception of what's happening in the world, and that feeds back to our mental model, our notion of subjective reality. And this is a continuous feedback loop. Now, in my piece in the issue, I add a little bit of extra detail to this basic model that Soros lays out. I noticed that inside this box of agent subjective reality, there's actually quite a bit going on. That there's some kind of internal model, a mental model, call it, inside our heads that's processing all this information and translating perception into action. And that also, quite importantly, agents in the system have goals. We're not just doing random things, we're trying to achieve something, trying to do something in the system. And then lastly, that this objective reality is taking place in some kind of an environment, a physical environment. And when you add these elements to that definition, you note a couple of important things. First, is that this internal model in our heads isn't static. It's updating all the time. It's changing in response to our interactions in the environment. So in addition to this big feedback loop that Soros sketches out in the picture, there's a little feedback loop going on inside our own heads as we try to understand and learn the world and process information and learn and hopefully improve our mental models over time. The second issue is that this environment that we're embedded in may be very complex, and complex in two senses. First, the environment may contain interactive complexity due to multiple interactions between different agents. So, my interaction with this room here is a complex interaction, particularly once you all get talking in the Q&A, because there are multiple agents interacting with each other. One person says one thing that changes the mental model of another person who says something else that changes the mental model of someone else, and so on. So there may be some very complex interactions between the agents and their mental models. And then second, that the complexity of the system may also contain dynamic complexity, that there's both positive and negative feedback in the system. Some interactions may be dampening, whereas others may be causing the system to engage in positive feedback. This is something Hommes will talk about in particular in his talk. So now, what does this mean, the fact that we have these internal models updating and they're doing it in this complex environment? Well, first we can ask what kinds of systems have this characterization. And clearly human economic systems have these characteristics of multiple agents, internal models, goals, interacting in a complex system. But so do other natural biological systems, ecosystems, for example. This description could also apply to that. But we could also imagine artificial systems that have this characteristic. So if you have a population of, say, stock trading algorithms, each of those trading algorithms would have an internal model, it would have a set of goals, it's interacting in a complex environment of both other people and other trading algorithms. So this notion of a reflexive system isn't necessarily just restricted to human social systems. It can also apply to natural and even artificial systems. Now, if we then ask, how would we characterize such a system, a reflexive system? Well, we can think of what I call a spectrum of complexity, that we can start way over on the left with very, very simple mechanical systems, a ball rolling down a hill, a pendulum swinging, the kinds of things you might learn about in a first physics class. Then if we start moving up, well, we could look at simple statistical systems, say, a gas in a balloon or something, where you may have some interaction between particles, but they're homogeneous and relatively simple. And those kinds of systems can be well described by statistical mathematics. And mechanical systems can be described by relatively simple analytical models. If we then sort of move up the spectrum to systems with more complex interactions, nonlinear dynamics, then it becomes harder to model and harder to know about those systems. And then finally, we have what are called complex adaptive systems, which are systems of multiple heterogeneous interacting agents, each with independent internal models and goals. And then we could lastly say that complex reflexive systems that have this interaction between mental models that Soros describes to be the furthest on the right. Now, if we then sort of look at what does economics study or know about, or how does economics characterize the economy, I would argue that economics has traditionally viewed the economy as a form of the kind of system on the left. A simple mechanical system or a simple statistical system. General equilibrium theory is a largely a kind of mechanistic theory. Likewise, a lot of theories and models in economics view the economy, like a ball of gas or something, a simple statistical system. But the reality of the economic system, whether it's the financial crisis, the Eurozone crisis, or any of the issues we were talking about here yesterday, is really much farther on the right, that it's this complex reflexive system. Now, what I argue in the paper is that has some important epistemological implications, that we can know a lot about stuff on the left. It's much harder to make definitive statements about the stuff on the right, and there may be some fundamental limits to our knowledge about the stuff on the right. And let me just describe very quickly what some of those limits to knowledge might be and why that means that some degree of fallibility is inevitable. First, there's some basic results that if you have finite data in a system, that discovering the correct model from that data may or may not be possible. We always have limits of knowledge of the initial conditions and parameters of the system, and when you have both positive and negative feedback, nonlinear dynamics, that becomes very, very important. And we will never know the initial condition of the economy, and we will never know all of its key parameters. That also, some of these systems simply may not be computable in finite time. There's some very fundamental results about computability, and yet, we only have finite time to actually try and simulate or do models of economic systems. And then lastly, we will never have a true kind of God's eye view of the system. We are always ourselves embedded inside the system, and this actually relates to the famous Gödel theorem. So, if you believe that the economy is this complex adaptive or complex reflexive system, we have to be humble in our ability to actually truly understand it, and in particular to forecast it. Now, it doesn't mean, though, that all is lost, that we just have to sort of throw up our hands and say, this system is too complex, we can't understand it. That we can actually still build useful models of such a system. And I've always liked this quote from the statistician George Soros, essentially all models are wrong, but some are useful. So we will have wrong models. They will always be wrong, but they may be very useful, and they may tell us things that we can do to improve the system. So even though these systems have limits to knowledge, they have regularities. There's patterns. They aren't random. They do have persistent patterns. And even though we can't directly access the reality of what's going on, we can build models that can give us a good enough approximation of what's going on to build a true knowledge. Now, there's a key difference between this kind of model building and some of what goes on in, say, physics, where what we're not coming up with is timeless laws. In such a system, there would be no timeless laws of the economy. They are always time-bound and contingent. It's much more like an evolutionary system that's unfolding over time. Biological evolution has regularities. We can have good theory about it. We can have good models about it, even though we may not be able to forecast it, and there may be not necessarily timeless laws about it. Now, even though we can't forecast the system, we can make predictions about the system that can be tested in the theories. Darwin famously made a prediction that you would find in the in the fossil record, certain fossils in a certain pattern, and nobody found them for a long, long time. And he actually got quite worried about it and said, well, if we don't find these fossils, my theory of evolution is just wrong. So he was doing what Popper called a falsifiability test. Darwin was saying his theory was indeed falsifiable. Well, sure enough, in the 1950s, with better microscopes, they found the fossils that Darwin was missing. So Darwin was able to make a scientific prediction. It wasn't a forecast of the future, but it was a prediction of an important implication of his theory that could be tested. And we can then see through this process of prediction and testing which models are better, which are worse, and create an evolutionary process of improving our models over time. So if we take this view that the economy is, as Soros puts it, reflexive, that it sits on this spectrum of complexity out to the far right end of being a complex reflexive system, that even though we will inevitably have limits of knowledge about the system, that through this evolutionary epistemological approach of building models, testing them, laying out their deductive implications, even though our forecasting may be imperfect, that those models can consistently improve over time, leading to growing knowledge about the economy and better policies and actions. This philosophical stance is consistent with what Stephen Hawking down on the bottom right calls model-dependent realism, that we acknowledge we're always limited in viewing the world through models. We'll never get a perfect understanding, but that we can nonetheless get knowledge. And I've also put up pictures of Popper and Hayek on here because I think that this philosophical stance integrates these four perspectives. So we'll leave it for my opening remarks. Don't despair. We are fallible. We are human, but we can understand the economy better than we do today, and we can make that knowledge useful for humankind. Thank you. And now I'm going to turn it over to Kars Hommes.
Okay, thank you very much, Eric. If I get this to work. Okay. Good morning, everybody. I've never given a talk so early in the morning, so I really appreciate there are so many of you here. The title of my contribution to this special issue is written down here: Reflexivity, Expectations, Feedback, and Almost Self-Fulfilling Equilibria, Economic Theory, Empirical Evidence, and Laboratory Experiments. So what I'm going to do is connect the ideas of reflexivity to some economic theory, and that has to do a lot with expectations feedback. And a very important feature in those systems are almost self-fulfilling equilibria that I will talk about. And then I'll show you some laboratory experiment to test this theory. So it's not working. Okay, this. So we don't see a lot. We've seen this. Okay, so that's the paper, that's the book. Let me start off with a quote by George Soros in his contribution to this special issue. He talks about what he calls fallibility. In situations that have thinking participants, the participants' view of the world never perfectly corresponds to the actual state of affairs. Okay, so stated differently, agents do not have rational expectations. Their expectations are not model consistent, but they make mistakes. Then another quote about reflexivity. These imperfect views can influence the situation to which they relate through the behavior of the participants. It connects the universe of thoughts with the universe of events. The influence is continuous and circular. That is what turns it into a feedback loop. So stated differently, what does reflexivity mean? It means you could view it as the economy as an expectations feedback system. Okay, here is, so a reflexive system is an expectation feedback system, and here's a diagram, a simplified diagram of the more complicated diagram that Eric showed. The feedback between beliefs, beliefs affect realizations, and realizations affect beliefs. So this is the feedback loop. And if you want to write down an economic model of that, a very simple version would be the model written down there, a mapping from the universe of heterogeneous beliefs into price realization. So the price would then be a function of all the beliefs in the economy, of all the agents in the economy. Now, what I'm going to show to you in a laboratory experiment is a simplified version of that, a simple mapping from average beliefs into price realizations. So there, the mapping, the price, just is a function of the average forecast of the price. So it's like a Keynes beauty contest where agents predict the average price and the realization is a function of that. And this is the typical economic model of an expectations feedback where this function f is derived from some economic theory. So how does traditional economics solve this feedback problem, this expectation feedback problem? Well, they just look at a fixed point. They look at a fixed point of the expectation feedback system and they call this the rational expectations equilibrium. Now that was introduced in a famous paper by John Muth more than 50 years ago. And here's a quote from Muth. And he makes a quote and is kind of a little bit worried about the possible heterogeneity in this system. So he says, allowing for cross-sectional differences in expectations is a simple matter because their aggregate effect is negligible. But he says not always, as long as the deviation from the rational forecast for an individual firm is not strongly correlated with those of the others. So modifications are necessary only if the correlation of the errors is large and depends systematically on other variables. Okay, so Muth kind of points to a potential problem for rational expectations equilibrium, namely the problem of coordination of errors. So what you want to know about this kind of expectation feedback system is, are individual expectations coordinated? And if so, do individuals coordinate on the rational price or on something else, some kind of boundedly rational equilibrium? So for a reflexive system, who is right? Muth, that it converges to rational expectations, or Soros, saying that there is more, there is reflexivity? Now, this is typically a question that should be tested empirically. And what I want to show you is show you some lab experiments and look at the empirical data, what lab experiments have to say about this question. So here are my simple examples. One with negative feedback on the left and one with positive feedback on the right. Now, negative feedback means on the left that the price is a decreasing function of the average forecast. So the higher the average forecast, the lower the price. Now, this is a typical situation in commodity markets where of a perishable consumption good, for example. So, for example, corn or the hog cycle model, where if producers have a high expectation, they produce a lot, so a lot goes to the market and the realized price is low. That's a negative feedback system. And you see the linear negative feedback map is the red line, and that has the unique fixed point, which is 60, which is the rational expectation solution. Now, on the right, you see a positive feedback system. It's the same equation, except for a plus sign instead of a minus sign. Okay, and typically a lot of these economic models have a coefficient, a slope, that is actually very close to 1. It's typically a discount factor. Okay, so, but when that linear map with positive slope, a slope very close to 1, as you can see in the picture, the red line almost coincides with the diagonal. There is a unique fixed point in the middle, which is again 60, which is the rational expectation point. But you already see now that in this positive feedback system on the right, in fact, every other point is almost self-fulfilling. Okay, and the question is whether in this kind of system, whether subjects could learn this equilibrium point, whether they can learn it under negative feedback or whether they can learn it under positive feedback. Well, let's test that in the laboratory. So we bring students in the laboratory, we give them a qualitative description of this economy, and we ask them to forecast prices, and we let in each period, the realized price depends on the average forecast of the subjects in the lab, and we let this economy run for 50 periods. Okay, and then the question is, who's right? Is Muth right? Does it converge to rational expectations? Or is Soros right? Do we get something else? Okay, so here are the experimental results, 2 examples. On the left, you have negative feedback market. On the right, you have a positive feedback market. And you see the results are very different. On the left, the negative feedback, the price, the red curve, quickly converges to the rational price of 60. And as you can see in the bottom plots, there are the individual forecasts. In the beginning, the individual forecasts are nicely heterogeneous. Then the price stabilizes, gets close to the equilibrium 60, and then expectations coordinate on the correct price of 60. So Muth is right. In negative feedback systems, it seems that the rational theory is working. And actually, Muth used this particular cobweb model in his seminal paper in 1961 as one of the examples. But now look on the right to the positive feedback system. The price does not converge at all. The dotted line at 60, that's the rational equilibrium, but the price oscillates around it, makes big oscillations around it. Why is that? Well, look at the bottom pictures where the individual forecasts are. You see that within 2 or 3 periods, the individual forecasts coordinate on a price close to 30. So they coordinate on something that is very different from the rational expectations price. And that's why the positive feedback market doesn't converge to 60, but oscillates around it. Okay, do we have a theory that can explain these experimental data? Well, here are more experimental data. On the left, negative feedback, they're all stable. On the right, positive feedback, they go everywhere. And here are some plots of a theory. So we have a behavioral theory of heterogeneous expectations. The theory is simple. There is a list of simple rules. Agents choose these simple rules and switch to better rules based on the relative performance of the rules. So what happens with this behavioral theory? Well, you see in the top graphs, again, the negative feedback market on the left, the positive on the right. The red dots are the experimental points. The green is the simulation of the behavioral model. And you see the model explains both convergence on the left and it explains oscillations on the right. Well, why is that? Well, in the bottom, you see the fractions of the strategies. And you see on the left that the purple strategy, which is an adaptive expectation strategy, is the winning strategy, and that stabilizes the market. But on the right, the blue and the green strategies are the winning strategies, and these are trend-following strategies. So trend-following strategies work well in positive feedback markets, and they amplify the oscillations in positive feedback markets. Okay, so let me just summarize what I said. Reflexive system is an expectation feedback system. Rational expectations is a perfect self-fulfilling solution. But in positive feedback systems, it's actually difficult to learn the rational solution. Agents rather coordinate on these almost self-fulfilling equilibria. Okay, and this property of almost self-fulfilling equilibria is a generic property of systems with a lot of positive feedback. So we have a behavioral theory that explains the data. Positive feedback markets are irrational in the sense that you get other prices than rational prices. And of course, for policy, this is very important because policy should take these bounded rationality, heterogeneity, and these almost self-fulfilling equilibria into account, especially in positive feedback systems. And we all know in finance and macro, there's a lot of positive feedback. Okay, thank you very much.
Is this going to come in? You just press this for this to come in?
Just give it a minute. It's a bit slow. Just give it a minute while they load your slides. They're just loading your slides. Just give it a minute.
Oh, they're loading the slides. Okay, so let me just say once we have a minute that I am pleased to be here. I will present work of the research program that INET is supporting and has been very generously supporting on imperfect knowledge economics. And we're grateful for INET to help us attempt to innovate, since we are in an innovation, in a way that true innovation can take place, namely without any restrictions and with betting that we'll get somewhere. So I hope to convey at least something about our efforts and let you judge whether we got anywhere. So this is based primarily on the work that I have done with Michael Goldberg and our colleagues and friends at the University of Copenhagen. Some of them are here. And that will appear in some place. I don't see it here. I need to see it to be able to. I need to see the slides because I can't. How do I get the slides to be seen on the screens? Mr. Chairman, the time is not running. Okay, here we go. So I think this order, and actually what I'll try to do in this presentation, I will try to connect it to the rest of the conference, and I'll try to connect it to what has gone before in this panel, and the two connections to what has gone before in the panel, namely there will be a connection between the view of the rational expectations hypothesis itself and its relationship to rationality, which Kars has accepted as being obvious. So that's going to be questioned. The second connection is going to be the connection between Eric's talk, namely even with a lot of data, we cannot learn the true model. We'll take a position that there is no true model. And then the question with all this, so what's the key to the talk? The key to the talk actually comes from the long-standing conversations with George Soros, and the talk is about what the session is about Knightean uncertainty. So the core of contemporary economics and finance theory is that unanticipated change in the economy structure and Knightean uncertainty are unimportant for understanding outcomes. The key to George's position, which was often emphasized, is reflexivity, but actually reflexivity happens to be the feature of every macro model that has been recently written for the last 40 years. So that couldn't possibly be the key. So what's the key? The key is actually the Knightean uncertainty, namely fallibility. And then, of course, with fallibility, reflexivity is important. So I will write down a simple model in which there is reflexivity and actually try to be extremely simple and very precise about what we mean by Knightean uncertainty. And the question I want to ask in the talk is, George had called in the piece he had this following provocative statement: any valid methodology of economics must explicitly recognize Knightean uncertainty. And the question that I want to ask is actually a Thomas Kuhn question: is there a new paradigm here? And what I mean is actually not paper falsification alone, but actually the Kuhnian question. We have a normal theory which is being taught everywhere. That theory has run into a number of anomalies, exactly as Kuhn describes in his classic work. I want to ask two questions. Kuhn usually from that moves to the idea that we will have a new paradigm. Here we are actually in a better position because we can ask the question, is there something that unites all these failures of conventional paradigm? And then ask the next question, if we remove that obstacle, would that actually lead to the new paradigm, and what that new paradigm potentially might look like? I won't have the time to go into this in detail in the little time that we have, but I'll try to indicate that that matters for everything. That matters for markets, for policy, for innovation, how innovation is funded, and the rest of it. And that one item is actually what is that Knightean uncertainty, namely the non-probabilistic uncertainty. And I'm not going to go into whether the system is complex or not. That connection between this needs to be precisely understood, and this is not something that we've looked into sufficiently closely for me to venture into that territory. I'll limit myself to the following simple proposition, that the Knightean uncertainty arises from the situation in which there's unanticipated structural change that doesn't allow us to write an overarching probabilistic model of outcomes from now to infinity. And that's the assumption that the standard theory makes. So let me just so I'm going to just, it's very similar to what Kars did. So just look at the first equation. This is not, you don't need, there's no mathematics here really. It's just to make this, because I have 15 minutes, I didn't want to burden us with the language. The first equation is exactly the one that Kars wrote. Just there's some causal variable x, there's a forecast of the next period's change in price, and there's some error term. That's every standard model in macroeconomics looks like this. It clearly has reflexivity, and it has also something else, and that something else is what we're interested in. It doesn't have Knightean uncertainty. So the question we want to ask is, and it doesn't have what Paul Davidson had called non-ergodicity, which is another way of talking about the system not coming back to the same position of unanticipated change. Those two things are actually very similar to each other. So how do we exposit first this business about not having a Knightean uncertainty? We have to ask that question first to understand what its implications are for macroeconomic theory, and then ask how would we fix that, and then what the implication of that would be. So it's trivial to just take the first difference of this equation, which is the second equation, and you notice immediately that until you say something about the changes, which are the deltas, this model has absolutely no implications for anything. It has no implications for policy. It has no implications for outcomes. It's simply not just that it's not a theory, it's not even a descriptive statement of the world. So what that shows is that opening the models to Knightean uncertainty, it's not the way to have an alternative paradigm. We need to do more. So in order to understand this point, we can just first ask very quickly what the prevailing paradigm is. Or the prevailing paradigm is a very simple paradigm. It specifies exactly all structural change. So if you look at this equation, there's, for example, delta beta t plus bt plus 1. If you suppose that the coefficient is constant through time, you suppose that the same behavioral and aggregate relationships describe the economy from now to infinity. That's the vast majority of macro models. There are some more sophisticated models that in our recent paper, we discussed them, where you actually have a prediction of change, but it's also determinate. Of course, in a talk like this, I can't talk about that. So that's a very simple model. The model forecasts ex ante at any time t0 that delta xt will be associated with delta pt in an exact way. Delta pt is equal to b delta xt. That's just a simple linear equation. The standard paradigm supposes such quantitative time series regularities are supposed to last for decades. The behavioral approach and the approach that Karls presented is in good part a response to the failure of this paradigm, but we can already see why this paradigm had no chance to begin with. The assumption that there's going to be the same time series regularities that describe the world from here to infinity deny the very importance of the things that this conference talks about, namely innovation. But it denies a lot more than that. It denies everyday management changes, rearrangements of floors, slight rearrangements of policy, which are unanticipated ex ante. It basically says that when the world starts, we can predict everything that happens into the future. Of course, that was the argument that led Popper to the whole idea of fallibility. This was the opposition, basically, to totalitarian systems. So what's the alternative? The alternative is to acknowledge that unanticipated structural change is possible, but to suppose that it exhibits some regularities at some intervals. I'm not going into the technical. So what's the difference? So the difference is clear. We do not assume the world is determinate. We do not forecast the future. We have predictions that certain relationships hold in certain intervals under certain conditions. Popper called this contingent predictions. I won't go into this. What I also want to mention, to complete this, that these predictions can be tested with exposed data. And that's exactly the work we've been doing with our colleagues and friends in Copenhagen. Now, let's now go to REH, which has already been featured as being a perfectly rational thing. So the first thing we need to understand that it's what is about REH that makes it perfectly rational. The most important thing is, what is actually REH? So the John Muth's quotes, this is it shows that John Muth wrote a great paper because everybody reads something else in the paper. I just want to remind you that John Muth was the first person who said that rational expectations have nothing to do with rationality. In fact, he said that at the risk of confusing this hypothesis with rationality, I will call it rational expectations. You couldn't be more explicit than that. In our book, Beyond Mechanical Markets, we discussed this. It's actually Bob Lucas that made it into rationality. But let's see what Bob Lucas's So the core insight of REH is that models must be internally coherent and empirically relevant. The usual focus of the discussion has been on internal coherence. People are incoherent. The world is incoherent. This is a trivial observation. This is an observation that says that the economist supposes something about the world. You cannot assume that the economist knows more than the market, or at least you shouldn't assume that the market as a whole actually cannot at least behave in a way that is consistent with the economist, with what the economist predicts. That would basically mean, in Hayekian words, that planning is possible. That's not something we can discuss here. So the key question is not whether REH is rational, but which model is relevant. And the prevailing paradigm has a very clear, simple answer: the determinant models. The models that assume away unanticipated structural change. What is the implication of this? In a great debate between John Cochrane and Paul Krugman, Cochrane has been misunderstood by Krugman when he said that all of this follows logically. What do you want from us? REH is logical. It's a logical implication of what we do. That's what rational people would do. Now, who was right here? You see, Cochrane was actually right, because once you assume that determinate models are the way to understand the world, that REH actually follows on logical grounds. So the key question is not whether REH is rational. The key question is whether determinate models are relevant. So how do we know that they're irrelevant? So what is the precise argument why they're irrelevant? And that, I have 2 minutes to finish? No. No, I spent 10 minutes. No, I mean, we didn't start.
That includes an extra 5 for the technical.
So the key point here is that the REH models are abstractions of rational, that it's not, I looked at this, 10 minutes, 32 I started. Karl Popper had argued that if there's such a thing as growing human knowledge, we cannot anticipate today what we shall only know tomorrow. That gives us an answer. REH models are abstraction of rational decision-making in a hypothetical world in which the growth of knowledge plays no role. In real-world markets, REH represents decision-making by irrational individuals. So is that the way that counts as time also? Okay? So that basically, this result, the second bullet point, to us settles the question whether REH is perfect rationality. What was the response of behavioral economists? REH is irrational, we need bounded rationality. And therefore, we're going to construct determinate models of this hypothetical world in which the individuals are, which are incoherent and that are therefore bounded irrational. In fact, in a determinate world, there is no way to define rationality, or all models are actually irrational, not just the behavioral models. So what's the answer to all this? Is to introduce Knightian uncertainty. The next question is, can we build economic theory that is based on Knightian uncertainty? The answer to this is, since I have little time, is already apparent in what I said. We need to replace determinate restrictions with qualitative and contingent regularities. Once we do that, we can actually do some, I promise I'll finish now. We can actually do a certain number of things. We get a resolution, actually, to the problem of rationality and consistency. Once the model is not watertight determinant model, we can go back to the question of consistency, and we actually formulate something called the contingent expectations hypothesis. We can bring back the behavioral insights, which are actually valuable. We don't have to deny that psychology is unimportant, only determinant models first, and we can bring in the Phelps' research program about autonomous role of expectations that REH banished by making expectations endogenous. The final thing I want to end is, we can actually start to begin to understand the financial market's essential role. And there are two roles of the financial markets. One is the one that the next session will be talking about, namely that they provide, as Bill would put it in his really terrific book, the liquidity to people who actually want to innovate, to provide funding for that. For that to be the case, there has to be some glimpse of fundamentals. They cannot be run by a phantom. Psychology may matter, but they cannot be run by phantom exogenous psychological impulses. And that's exactly, so you need a theory in which will bring fundamentals back to expectations. And that theory cannot be a mechanical REH theory. It actually turns out that when you go to partly open models, you can have that theory and actually get rid of the efficient market hypothesis that markets do things perfectly. So what do you emerge with? You emerge with something called the contingent markets hypothesis. And that provides an intermediate view. Markets do play an essential role in allocating society's savings to the most promising projects, but they do so imperfectly, even in the course of their normal functioning. Thank you.
So I'm not even going to bother talking until the slides are up. Actually, my remarks are going to be quite brief because I'm very interested in the debate that ought to emerge between the other speakers. And they're also brief because I'm a philosopher and you economists are never interested in listening to us philosophers. Let me begin. And of course, I'll have all the same problems that everybody else did. No, I won't. So Eric's paper for the Journal of Economic Methodology is an extremely interesting one and repays some careful attention, certainly by philosophers and people interested in the methodology of the social sciences broadly, in addition to economics. And I want to quickly review the main features of that argument. And here I'm reprising some of the remarks that Eric made at the outset of our talk. He identified 8 features of a reflexive system. Now, I think actually there are 6 features that are essential for reflexivity as a general empirical phenomenon. And I've given them in this first slide and a little more about each of them. There's an environment or a setting, and of course the environment isn't the physical environment, it's the environment composed of the causally salient features of the environment for the particular subject under study. So in biology, those salient features will be quite different from what they are in economics, for example. And then there are agents. And an agent is nothing but an item in that environment that is behaving in a teleological or a teleonomic way, a goal-directed agent, an agent whose behavior either approaches and maintains some equilibrium value or moves in the direction of some endpoint. And that endpoint is given by, or the equilibrium value is given by a goal. That's the third point. And the agent's behavior is under the control of 2 other factors identified in Soros's work as the cognitive and the manipulative functions. The cognitive function simply takes in the values of variables in the environment, treats them as information, and compares them to the desired goal state. The manipulative function then chooses those behaviors which will reduce the difference between the environmental actual variables and the goal state's values. And this is all done by the cognitive manipulative function are together, harnessed together by an internal model. This is Eric's term for, of course, in the human case, the cognitive apparatus that guides our behavior. The result of systems that are characterized by these 6 features are, of course, reflexive systems, and the most well-known and well-studied in ecology and evolutionary theory is the behavior of predators and prey. And here's a standard off-the-shelf model of how predator and prey behavior is reflexive in an environment. And this set of curves can be realized by wolves and caribou, or lynx and hare, or humans and their prey in a hunter-gatherer system. The predator's population is under the control of the supply of the prey, and the the population lags behind the prey population because of overshooting and undershooting. The phenomena is fairly well known, and of course there's a nice stable equilibrium here, an equilibrium represented by the persistent repetition of the curves. In order to get Sorosian reflexivity and uncertainty, we need to add two further features, and these are features that Eric identifies in his account. The internal model which the individual agents employ to connect the cognitive and the manipulative function in order to choose behaviors, either the predator's behavior or the prey's behavior, or in the case of humans, say the behavior of speculators on a market and the behavior of CEOs running businesses, the models are updated. They're updated continually. That is, the particular ways in which the individuals identify the salient causal features and the computations they effect on those features in order to calculate outcomes continually changes. It updates in Eric's terms. But of course, we need to understand updating as not necessarily improvement. The internal model may change in ways that reduce at some times or even persistently the ability of the agent to attain the object or maintain the equilibrium state. And finally, there's complexity in this particular sense that the behavior of each individual agent, which is determined by the agent's internal model, is in turn affected by the behavior of other individuals. Reflexivity, of course, but the reflexivity affects the internal models and continually changes them in ways that cannot be predicted. And when you add these two additional features to the kind of stability that you have in a biological setting in which the agents, in the case of predator and prey, for example, do not constantly change their internal models, or if they do, change them very slowly and for well-understood reasons, instead you get the Sorosian reflexivity and uncertainty. And the difference between this curve and the biologist's curve, this is a curve from George Soros's Alchemy of Finance, the difference between this curve and the biological curve is that the relationship between the two curves here ceases after one cycle. And it ceases after one cycle because of the role of uncertainty, because of the way in which the internal models change owing to the observation by the agents of the behavior of other agents and the unpredictable character of the way those models change. The rest of my talk is very briefly a set of questions for Frydman and Goldberg, because I think that Frydman and Goldberg's model are the best example of the way to try to take seriously the kind of reflexivity and uncertainty, Knightian uncertainty, that Soros has drawn our attention to. Now here's a passage from a very recent paper by Frydman and Goldberg. The contingent and qualitative character of the conditions that IKE, incomplete knowledge economics models, place on structural change is crucial to their ability to deliver empirically relevant, and by that I think they mean testable and confirmed, accounts of the swings in asset prices and risk. Qualitative regularities, like market participants' tendency to revise their forecast, that is, the internal model changing, to revise their forecast in guardedly moderate ways, the internal model changes slowly, for stretches of time, play a key role in an IKE model of persistent upswings and downswings. But model changes. Because these conditions are also contingent, they're consistent with irregular structural change in macroeconomics and finance models, in particular, the finance and the macroeconomic models of the agents. By specifying its models as qualitative and contingent, IKE accounts for the irregular asset price swings that we observe in real-world markets. The markets don't look like the Lotka-Volterra predator-prey relations in that nice curve I gave you before. They look like one-time snapshots of Soros's reflexive model from the Alchemy of Finance. And the example that they use in one of their recent books to describe the rational expectations approach and their improvements on it comes from their discussion of Messe and Rogoff's exchange rate disconnect puzzle. Here's another quote from Frydman and Goldberg. Messe and Rogoff's results had a profound impact on the literature. They found that none of the models examined, models for currency fluctuation, produced exchange rate predictions that would enable a forecaster to do any better than merely flipping a coin. This was the case even though the predictions of these models were based on the actual future values of these fundamentals. The results thus suggest that possession of such information provides absolutely no benefit to the forecaster. The implication drawn by most researchers in the field seems to be obvious. Fundamentals play absolutely no role in currency fluctuation. So much for Rogoff and Messe. Now, Frydman and Goldberg attempt to address the problem that was raised by Messe and Rogoff, and to show how their model accommodates the data that Messe and Rogoff introduced, in particular to show how when you break that data down into shorter time periods, the Frydman-Goldberg model successfully predicts currency fluctuations on the basis of fundamentals, but ceases to do so at critical points, 6 of them in their data set, and then begins again to be successful for limited periods. And what they write is that no one can foresee these shifts, these 6 shifts in the particular data set from Messe and Rogoff, but in general, no one can foresee shifts in monetary or fiscal policy, let alone other factors underpinning other breakpoints in this data. Now, the question is why not? And the answer they give, and Roman touched on it in his presentation just now, is that as investors underlie their internal models in Eric's terms, as investors alter their understanding and their assessment of the future, they influence the process driving prices because, of course, they influence one another's internal models. Such contingent change leads to new states of affairs, new correlations between fundamentals and future outcomes emerge, and old ways of thinking lose their forecasting powers. Formerly successful internal models no longer work. Now, why is this a council of despair? Why do I so label it? And this is the question I'm going to want to put to Roman, and I'm interested in hearing the rather upbeat response that Eric, too, would have given how he ended his own presentation. IKE models, incomplete knowledge economic models, allow for radical and unpredicted change in internal models of some, or many, or even of all of the agents. And there, in IKE, is at least no basis for timing when this happens. Of course, this sounds like a criticism of Frydman and Goldberg. Why don't they give us the timing that will enable us to use this theory to make rents? But it's not a criticism, because I don't suggest, and I think if Soros is right, we can't expect anyone to do any better. In fact, rational expectation models and ones that insist that profits will never be left untaken, they'll do worse than Frydman and Goldberg. But this, I think, is the take-home message of Soros's point about reflexivity and uncertainty, and the explanation of why Soros's point is right and why we need to take it seriously, and perhaps why it needs to permanently limit our expectations about what we can do by way of providing a predictively powerful, as opposed to merely retrospectively ex post facto explanatory theory in economics. That is vouchsafed to us by these 8 conditions that Eric has identified in his own paper. Thank you.
Thank you very much, Alex. And since you did a very nice job responding to the different papers, I won't try to summarize or synthesize across the presentations. My only brief comment before we get into a short Q&A is that out of the presentations, we have a sense of this, the interaction of internal models is a core issue in understanding our limits to knowledge, fallibility, and Knightean uncertainty.
Yeah, and I wanted to add, That Kars's work is probably the best empirical substantiation of this point, and it's the reason that I was silent on it. I think it speaks for itself.
And I was reminded of this nice phrase that Brian Arthur has. It's not rational expectations, it's an ecology of expectations that's constantly evolving and developing over time. Now, because we started a little bit late and had some technical problems, I am going to overrule this sign here saying no Q&A and open it up for a few minutes of Q&A, because I know that there are a number of people who want to raise some points, and I'll start with you, Paul, down in the front. And if someone will bring you a microphone.
Thank you. Paul Davidson, Journal of Post-Keynesian Economics. There's a quote from Knight, page 210, about what the conditions for uncertainty is under his, and his quote is, and I quote it, the universe may not be knowable, but objective phenomena reality is certainly not knowable to a degree so far beyond our actual powers, and therefore any limitation of knowledge due to a lack of real consistency in the cosmos over time may be ignored. Now that is what statisticians would call an ergodic statement. That is, the future is already predetermined. He says you can't assume there's a lack of consistency in reality over time. I even have a quote by a Nobel Prize winner who says that basically production in every state of nature, in every contingency, is precisely what it would have been had the information not been available. So basically that's the same Knightian uncertainty. The future is already predetermined. Keynes, on the other hand, not knowing statistical theory, criticized Thunbergen's method and said that the problem with econometrics is that the economic data is not homogeneous over time. He didn't know what he was stating, because non-homogeneity of economic data is a sufficient condition for a non-ergodic stochastic process. And for those who are not statistically oriented, non-ergodic merely means that probability distributions that exist in the future are not the same as the probability distribution that exists in the past, and therefore you cannot use past statistics to predict the future. I have a quote here from Soros, who says basically that people create the future, and he actually specifies in this case that he rejects the ergodic hypothesis because it's not with reflexivity. So if you're going to talk about uncertainty, you better talk about Keynesian uncertainty, and just to add why, if the future is already predetermined, government policy cannot change the equilibrium, whatever that is. If you believe in Keynes uncertainty, then government policies can affect or create the future, and that's what reflexivity is. So you just got the wrong concept of uncertainty.
Thank you, Paul. I'm going to take two more questions, then I'll let the panel respond. The gentleman standing up in the back.
Yes, my question is about the word fallibility. I just need a little bit of clarity on that, because I see in the models when you're talking about cognitive functions and manipulative functions, if fallibility is the nature of the human being, the condition of mankind, can you be more certain by saying that fallibility has an element of profiteering, which is what we've all seen, into the trillions of dollars, and therefore it's probably got a criminal aspect to it, which is easily predictive. And I just wondered if the word fallibility is interchangeable with the criminal mind.
Thank you. Gentleman standing in the very back by the door.
Hi, I just have a question for the second last speaker. When he was talking about, the market not being efficient in allocating resources, talking about banks not being efficient in allocating savings of society. Well, that might well be true, but I don't see any other way of allocating resources except through the market. Markets might not be efficient but it's not just about markets. That's why sometimes philosophy is important. It's about freedoms, morality, and justice. So if you say markets are not efficient in allocating resources to savings, what is efficient?
Thank you. We're going to leave it there. I'm going to let the panel respond. So we've got Keynesian uncertainty versus Knightian uncertainty, and also I think Paul correctly mentioned we didn't mention the word ergodicity in our talks, which is important. We had a question about does fallibility extend beyond just a kind of cognitive notion to maybe a moral or even criminal notion, and if markets aren't efficient for allocation, what is? Who wants to start? Roman? And let's keep, we'll need to keep things brief because we will get kicked off in a few minutes.
We are nowhere near have the time to, but on the difference between Knightean and Keynes' uncertainty, with all due respect to Paul, and I have a lot of it, I disagree. Keynes' criticism of Tinbergen is exactly that Tinbergen doesn't take into account the fact that there is an unanticipated structural change in the economic model, in addition to not knowing what the causal factors are. And therefore, there is ultimately, in probabilistic terms, a call for the fact that not all uncertainty can be represented in probabilistic terms via large-scale econometric models. So I don't see the difference. On the question that was specifically addressed to me, how can we do better? The difficulty we have here is basically, what I try to highlight is the fact that the theory that we have about swings is the theory about how markets do the job. So if we think it's all external psychology, we basically are saying that markets don't do any job allocating resources. No one who advocates the behavioral theory advocates closing the financial markets, but that it would be the implication of that theory. And if the markets don't do it perfectly, who does it? But the fact of the matter is, in fact, no one does it. That's why there's no true model, and that's why there's no true fundamental value. These things evolve over time, and the idea of the market is that the information and values that the market participants have, plus that gives an opening to the government, is actually, in some sense, superior to the one model that the economist writes down, which is basically the determinant model, which is basically the REH view. So that is, as Alex, thank you very much for saying that, pointed out, this is the best we can do. And I just want to remind you that history teaches us that the attempts to do better have not really worked out very well. And all you need to think about is Eastern Europe, Russia, China in its early stage without financial markets and the rest of it. And that may make you think that there's a great, so what we need a role of government, we need to recognize that markets do a job, and we need to have a theory that matches to this. And the claim is that the theory that omits Knightean uncertainty is the theory that is unable to deliver that. That's basically as simple as that.
Unfortunately, I'm sure we could keep going quite a bit longer, and I apologize to both Alex and Kars because I know you want to get in, but we are getting the "you must wrap up now or else" sign flashing up on our screens. So it just leaves it to me to first, I actually want to thank someone who wasn't here on the panel today, which was George Soros, who was the inspiration for all of this work and a fascinating discussion, and thank him for his courage in raising these very fundamental issues over the past decades and stimulating this debate. I'd like to thank Wade and John as the editors of the Journal of Economic Methodology, and I'd like to thank very much our panelists for a stimulating discussion. And thank all of you for getting up so early.
Thank you to the moderator and panelists. While people are entering the room for the next panel, which will begin in just 5 minutes, we'll show you a video about CG. So please remain in the room, and we'll begin promptly with our next panel.
Around our planet, humanity faces many shared and serious challenges. Recurring global economic crises, climate